Good day everyone, my name is Dr. Akinshola Jet. I'm presenting a paper on artificial intelligence enabled deep learning model for diabetes prediction using deep belief network with Bayesian optimization for the 2023 International Conference on Computational Science and Computational Intelligence holding at Las Vegas, USA from 13 to 15 December 2023. These are my co-authors, Dr. Agbaje S.A. from the Department of Computer Science and Industrial Engineering, First Technical University, Professor E. Olajubu from Obafemi Awolowo University, Ile-Ife, and Ms. Lawal A.O. from the Department of Computer Science, First Technical University, Professor Aderounmu G.A. from the Department of Computer Science and Engineering, Obafemi Awolowo University, Professor Adegun M.O. from the Department of Computer Science, University of Zululand, South Africa. The table of contents is as presented with introduction, related work materials and method, result and discussion, conclusions, and reference. Diabetes is one of the major health issues that affect more than 10.5% of the adult population across the globe, and this has made it to be a very delicate disease. Many AI-based models have been proposed to enhance the early detection of similar diseases, but unfortunately, the solutions have not been able to take care of how active the training model processes are, and in that case, it has made the neurons to be triggered during the testing phase. Machine learning approach can be applied to diagnose patients with diseases based on some features such as glucose level, blood pressure, skin fitness, insulin, and body mass index. This research implements deep learning model with Bayesian optimization to build an efficient model. Deep learning algorithms such as deep belief network, long short-term memory, recurrent neural network with Bayesian optimization were applied on the diabetes database using splitting ratio of 80 to 20, and the algorithm performance was compared using performance metrics such as accuracy, F1 score, recall, mean absolute error, mean square error, loss function, and precision. The contribution of this study includes utilization of type 2 diabetes dataset for this research in order to determine how effective the model could be. Application of deep learning algorithm of diabetes dataset to predict diabetes. Utilization of different evaluation metrics in order to determine the goal of the model. Application of Bayesian optimization to improve the performance of deep learning model are some of the contributions of this related work. There are 4 popular machine approaches for typical machine learning problems. However, there are limitations arising from the study. From the previous studies, such as small dataset, the dataset instances mainly focus on female within the age range of 21 years, which are not the real population of diabetic patients. Also, the belief network has a kind of approach that if it is not well labeled, can result into having unreliable and inefficient predictive model. Hence, DBN is not only capable of learning nonlinear relationship by deep belief network structure, but also more robust to overfitting them than the deep neural network. There are existing solutions that have been proposed in relation to modeling and predicting diabetics. This solution failed to continue, and they lack the combination and comparison with other deep learning models such as RNN, LSTM. There has not been utilization of hyperparameter optimization to achieve better performance results for reducing false negatives. Artificial intelligence has been applied in several domains, and there have been many breakthroughs, some of which are novel and they are being used to solve some of these problems that we encounter every day. The goal of artificial intelligence is to construct machines that can stimulate cognitive capabilities associated with human intellect. AI system is categorized into some of the following areas: machine learning, which involves training a model on data to recognize patterns and make predictions; natural language processing, that focuses on the intersection between computer and human through natural language and enables the understanding, interpretation, generation of human language that facilitate communication between computers. Deep learning has come into play as a result of the efficient utilization of the models that mimic human brains and the neurons that functions in the way biological models are being propelled. The neurons of the deep learning models are active during the training phase. These sets of neurons are also triggered during the testing phase. There are numerous deep learning models such as deep belief network, recurrent neural network, and long short-term memory, and these has made these solutions to be of importance such that multiple layers to the data is transformed as it passes through the network, and that makes them to actually be referred to as deep. There are several stages for any deep learning model, particularly deep belief network. We have the pre-trained stage, in which case each layer of the DBN is trained independently as a restricted Boltzmann machines. And we also have the fine-tuning. This stage adapts the deep belief network to specific tasks or label materials and methods. The research utilized the diabetes dataset from digital healthcare repository known as electronic health records. It consists of 9 columns such as gender, age, hypertension, heart disease, smoking history, body mass index, heart level, blood glucose level, and diabetes as the predictor, which is the Y variable. There are 8,500 diabetic records, 91,500 non-diabetic records, which are used in developing the model. There are data preparation and preprocessing tools that were employed. The data processing includes the data cleaning, data normalization, feature scaling and encoding, and deep learning models such as deep belief network, recurrent neural network, long short-term memory were also modeled by using data mining approaches in relation to training, validations, and testing. In order to have an efficient model and to avoid irregularity in the data, some tools such as MIMA scaler were used, and functions such as scikit-learn, they were employed in the Python library, and libraries such as NumPy pandas were used to model for training and building an efficient model. Some performance metrics were used such as loss function accuracy, recall, left-hand score predictions, among others. In order to validate the reliability of the model, there was determination of the ratio of false positives to false negatives. Architectural model for diabetes prediction. Architectural model was developed, which consists of 6 phases. The phase 1 deals with data acquisition and data preprocessing. Phase 2 deals with the classification of the prediction in relation to DBN, LSTM, and RNA. Phase 3 consists of fitting the trained model, predicting testing data set by generating the performance evaluation metrics such as loss function, accuracy prediction, among others. Phase 4 deals with optimization of the metric result using Adam for fine-tuning, and then Bayesian optimization approach for the parameter optimization. Phase 5 consists of deploying of the chosen model, and phase 6 deals with the prediction of the diabetic system. The process flow for diabetes prediction. This consists of one input, 10 processes one decision and one output. Phase 1 is so essential. This is where the handling of missing value, data normalization, standardization were performed. Second phase deals with the tuning of the normalized data. Third phase is the formation of the new data set which has been tuned with normalized data. Fourth phase is the aspect that deals with the splitting ratio of 80 to 20, 70 to 30, 75 to 25, and 60 to 40. This was done to determine the best ratio such that the number of false negative and false positive can actually be so determined that will be used in building an effective model. Fifth process is building model using the optimized DBN. The sixth process deals with the hyperparameter where Bayesian optimization was employed. Phase 7 is the implementation where the validation was carried out and the decision regarding determining whether the Bayesian optimization has produced an optimal result. Result and discussion on training sets. The comparative analysis of training dataset results from the algorithm after optimization is shown in Table 1, Figure 3, Figure 4, where the graphical representation of the comparative analysis were elucidated. The models shows that the long function with DBN is 0.1512, for the LSTM is 0.1527, for the RNN is 0.1567, and the accuracy for DBN is 94.66%, LSTM 94.63%, RNN 94.43. This shows clearly that the highest accuracy happens to be 94.66, and that was from the model referred to as the belief network. The mean absolute error of the DBN shows 0.0858, while that of LSTM is 0.0886, and that of RNN is 0.0892. This shows clearly that if the mean absolute error tends to 0, that shows the reliability of the model, and the best at this point in time happens to be 0.0858 for the deep learning model. The precision, the recall, the root mean square error were as presented, and still clearly showing that the DBN model performed better than the other. From the graphical representation, precision was very high. That shows that the model is reliable. Also, the mean absolute error tends to 0. That shows that the error rate in the model was significantly low. And the figure 4 shows the accuracy, where DBN happens to be the one with the highest accuracy value. Now, the result in Table 2 shows the optimization on the testing dataset. At this point in time, the accuracy was increased from 94 to 95.89, and at the same time, the mean absolute error became relatively low again. And the advantage of this is that when a model is optimized and the accuracy tends to 100%, it means that the predictability and the reliability were well assured. And it has also been noted that the precision value was also on the rise, where 0.9458 happens to be the precision for the deep learning model, 0.9037 happens to be the precision for the long short-term memory, and 0.976 happens to be the precision for the recurrent neural network. After the optimization, there was a kind of adjustment, and that adjustment has brought about this significant difference in RMSE, MSE, and MAE on testing dataset, and the comparison of the model's accuracy after the optimization was shown in figure 6. The graphical representation of the comparative analysis on the testing dataset has validated the utilization of Bayesian optimization for conclusion. The experimental results show that the performance of the deep learning model can be improved by using Bayesian optimization, as evident from the result after optimization. Optimized model can be used to achieve a faster training process with higher prediction, because as the mean absolute error tends to 0, that shows that the model can perform faster. The DBN can be used as the golden model to predict type 2 diabetes. The study recommends the prediction of type 3 diabetes. Also, the application of other optimization models and hyperparameter tuning techniques for increased precision and accuracy. These should be considered for that study. These are the reference. Thank you for listening.